Okay, so here, if I draw a green one, then all I have left is red or blue. 3 out of 9 are red, 6 out of 9 are blue. If I drew a blue one first, then I could draw a red, a green, or a blue next. Let's see, I have 3 red ones left, I have 1 green one left, and I have 5 blue ones out of 9 left. Now here are the questions. The questions are red, then green. So that means red, then green. How do I get here? How do I get to that spot? Multiply the probabilities. 3 out of 10 times 1 out of 9. And you got 3 out of 90, yeah? Good. 3 out of 90. Now, red given blue. This is the one people were kind of like, what do I do about that? Red given blue. If I'm saying what's probability of red given blue, I'm giving you blue has happened first. What's the probability that I've drawn a blue first? Nope. I've given you the first marble is blue. What's the probability the first marble was blue? 100%. I've given it to you. If I give you male, I want to find the probability of male, given it's yellow, what's the probability the puppy's yellow? 100%. I'm telling you, whatever I'm giving you, I'm telling you has happened. So the probability of red given blue means that the first marble was blue.
But you take it out regardless, right?
Yes, you do take it out. But 100% it was blue. Everybody understand what I'm saying?
Yeah.
So red given blue means what's probably red given I am standing right here. So 100% I'm here. What's probably of red? 3 out of 9. Does that make you guys follow me?
Yeah.
So we don't multiply 6 out of 10?
No, you don't. It's just 3 out of 9. Okay, so someone said, you guys focus here. Someone said, well, why don't you multiply these two? That would be the probability of blue then red. Because how do you find the probability of blue then red? The probability of blue has the probability of red given blue. Do you guys remember that? From our, right? So this is the probability of blue times the probability of red given blue. That's the probability of, right? That's the probability of blue and red. Do you guys remember that? That's where that formula comes from, right? Probably of blue and red. Probably of blue times probably of red given blue. That's this spot here. So this is the probability of blue. This is the probability of red given blue. Good? Make it sound okay. Thank you. Okay, move on. So that equals 6 over 10 times 3 over 9. 18 over 9. This is the probability of blue then red. Okay. Alright, so then the next question was, probably they're both the same color. How can they both be the same color?
There has to be more than one of each.
What's one way? Red, red. What's the other way? Blue, blue. Because green, green can't happen. Everybody on board with that part? So you find the probability of red, red. And you find the probability of blue, blue. So what's probably red then red? So red then red is 3 over 10 times 2 over 9, 6 over 90. What's probably a blue blue? 6 over 10 times 5 over 9, 30 over 90. So is it, if I draw two marbles, can they be red and red, red then red, and then also be blue and blue at the same time? No. So how can I draw two of the same color? Red, red, or blue, blue, or as we add. So we would add those. And you guys would end up getting 36 out of 90 as your final answer. Good? Yes? Okay. The next one is red on the second draw. So here's the easy way of finding that. Easy way is this. Imagine that there's a bunch of marbles in here, and they just are going to get dropped into a. However, I end up when I finish mixing these up, wherever they stand is where they will be forever. So whenever I pull them out, they're going to come out in this order: red, then white, then white, then white, then red, then white, then green, then white, then red, then white. This is the order they're going to come out, no matter what. This is always good. This is going to be first, that's going to be second, that's going to be third. So what's the probability that the green one will be first? Great. What's the probability that the green one will be second? What's the probability that the green one will be in any position? What's the probability it will be in the last position when I finish shaking this bag? 1 out of 10. What's the probability that the green one will be in the third position when I finish shaking this bag? What's the probability that the green one will be in the second position when I finish shaking this bag? 1 out of 10. What about the red one? What's probably the red one will be in the first position? Oh, a red one. Any red one. 3 out of 10. What's probably any red one will be in the last position when I finish shaking the bag? 3 out of 10. What's probably the red one will be in the second position? A red one will be in the second position when I finish shaking the bag? 3 out of 10. So, no matter what, the reds have a 3 out of 10 chance of being in any of these positions. So the probability that the red is in the second spot on the second draw is 3 out of 10. Now, you guys, I'm going to get some non-believers out there. So if you want, we can do this. We can find this probability, red second, right? Or red second, or red second, and add them up. What are those? Let's see, 6 out of 90. We also found this one already, 18 out of 90. What's this one over here?
3 out of 90.
Yeah, it's 1 out of 10 times 3 out of 9, so it's 3 out of 90. We're going to add that one, right? Because it could be red, or green-red, or blue-red, right? So we're going to add those up. We'll get 6 out of 90, plus 3 out of 90, plus 18 out of 90. If we add those up, we end up getting 27 out of 90, which is 0.3. 3 out of 10. Good? Does that make sense? What happens is, if you don't know what the first one is, then it's like it never happened. It doesn't matter. Okay? Why is this important? Because there may be some day when you guys are playing poker and you're going to be able to count your outs. All the cards that got dealt out to people who folded their hands, you don't count those cards. All you care about are the cards that you can see that you know. The rest of them just don't matter. Okay. All right, the last thing we're going to tackle is complementary events. So we're a little bit tight on time here. The complement of an event E, denoted by E bar or EC, it's everything that's not E. Everybody, you guys remember that? So it's the rest of it. The thing I want to get across to you is that the probability of getting at least one, what's the complement? Either I have at least one sibling, or I have
0.
I'll try it again. I have at least one sibling, or I have 0, none, no siblings.
Exactly.
All right, if I count the money in my pocket, the bills in my pocket, I either have at least $1 or I have $0. So the complement of at least 1 is none, right? So for example, the probability that I roll this dice 3 times and getting at least one of them to be a 4, the complement of that would be 0 4s, getting no 4s at all. And that's an easy way of finding that probability. 1 minus probability of no 4s. Right, because they have to add up to 1. So if I need to find the probability of at least 1 4, I can just find the probability of no 4s and subtract that from 1. Let's take a step back real quick. All right, I'm talking about I want at least 1 4 in 3 rolls of dice. How many ways can I get at least 1 4? How many 4s would that be? What was that? I'm rolling it 3 times. I need at least 1 4. How many 4s is that? 3 4s, or I'm going to roll this 3 times. I want to know how many ways can I get, if I have at least 1 4, how many 4s is that? 1 or 2 or 3. Good. 1 or 2 or 3. Everybody on board? That's at least 1. All right. So let's list out how many ways there are of getting 1 4. I'll give you the first one. I'm rolling the dice 3 times, and only one of them is a 4. I could have gotten that by going 4, then not a 4, then not a 4. Right? That's 1 4. What's another way I could do it? Not a 4, then a 4, then not a 4. Everybody on board? Yes. So the first roll was not, the second roll was, yay, the third roll was not. What's another way of getting exactly 1 4? Not, then a 4. Good? 3 rolls. Okay, how many ways can I get 2 4s when I roll the dice? 4, 4, and then not?
4, not 4.
4, not 4. And? Not 4, 4. How many ways can I get all 3 4s? 4, 4, 4. Good. So I can either find all 7 of these probabilities, compute them all, and add them up, or I can just find the probability of no, 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 and subtract that from 1. Way easier, right? Because the no, 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 and the yes, yes, yes are really easy. There's only one way of doing them. These guys, there's a bunch of different ways, combinations of getting that, right? So it's a little bit harder. But the all or the none, super straightforward. I don't even need a tree for it, because here I'll show you what I mean. So here are my at least 1 4, right? Here is my no 4s at all. I can either find these 7 through this probability tree and add them up, or just find this guy and subtract him from 1, because all of these should add up to 1 or 100%. And like I said, the beauty of it is this one's really easy to find, because they're all the same. I don't even need a tree. What's probably I roll that dice and get a 4?
1 out of 6.
1 out of 6. What's probably I don't get a 4?
5 out of 6.
5 out of 6. And they're independent. Each roll is independent. It doesn't depend upon what you rolled before. Everybody agree with that?
5 out of 6.
So they're all 5 out of 6. Good? So I can just find that. No and no and no. I'm going to, and we, come on guys, and we, don't make me throw something at you. And we,
Multiply.
and we multiply. Because you have to, right, you have to pass more tests. And we multiply. Everybody say, and we multiply.
And multiply.
Great. Say that to yourself 20 times on the way home.
And.
and it'll go better, right? It'll flow better. All right, so here we want a no. We want this. Oops. Undo. We want this pathway here. So 56 times 56 times 56. 125 over 216. And again, we don't need a tree. You guys give me 2 minutes. Be quiet so we can get out of here. Since there's only one way of getting no 4s, we don't even need a tree. Just 0.56 to the 3rd power. All right, because I'm going to roll it 3 times. If I was rolling it 4 times, I'd do it to the 4th power. So all I have to do is take that probability, subtract it from 1, and you'll get it. You can do it as a decimal. I'm totally fine with that. That's no problem. So lab problem number 3 we're going to skip. You guys do lab problem number 4. That's the last thing we're doing. You have 2 minutes to do it in. 2 minutes.
What is it?
Lab problem 4. Neckwear.
That was a new one.
Shirley, can you read it out loud for people louder? Yeah, read it.
The Neckwear Association of America reported that 3% of ties sold in the United States are bow ties. If 4 customers who purchased a tie are randomly selected, find the probability that at least one purchased a bow tie.
Great. I have 4 customers here. I need to find the probability that at least one of them bought a bow tie. What's the probability that she bought a bow tie?
3%.
3%. They're not equally likely. 3%. What's probably she did not buy a bow tie? 97%. So I need to find the probability that one of them did, or 2 of them did, or 3 of them did, or all 4 of them did. Or I can find the probability that they all said no to me. No bow tie. No. And subtract that from 1. So probably she did not buy a bow tie. Probably he didn't. Probably he didn't. Probably she didn't. Okay, so take a minute with your neighbors, find this.
Whatever that.
So 4.
Oh, I thought that was like decimal on top of the fraction.
So again, the probability that at least one buys is 1 minus the probability that none of them buy. So you have to find the probability that none of them buy. This is what you guys have so far?
Yes.
Okay, what is that? 0.885.
8.5.
So then the probability of at least one?
1 minus that.
Yep.
Exactly.
Everybody, this is making sense?
Yeah.
All right, have a good weekend.
Thank you, you too.
I mean, yeah, or you can write it as 11.5%, either one's fine. Yeah, totally.
Bye, guys.
Take care.
Bye, everyone.